Now see, we already discussed up to 136 page number of your NCERT book. Now all of you take out NCERT book. Now see the mass. So what will be the definition of mass? So write down mass of an object. Write down mass. All of you write down mass of an object. Mass of an object is. First, I done some properties of mass. Mass of an object is constant. Mass of an object is constant, and does not change from place to place. So this is the first property, that
does not
does not change from place to place. Mass of an object is constant and does not change from place to place. Okay.
Yes, sir.
So write down, it is defined as the write down, it is defined as the quantity of matter. It is defined as the it is defined, definition. It is defined as the It is defined as the quantity of matter. It is defined as the quantity of matter contained in a body. Contained in a body. It is defined as the quantity of matter contained in a body. Okay.
Yes.
1 minute. So what is the definition? First, mass of an object is constant and does not change from place to place. It is defined as the quantity of matter contained in a body. So it is defined as the quantity of the matter contained in a body, and it is a scalar quantity. Do you know what is scalar quantity? Vector quantity? Anyone? What is scalar quantity, vector quantity? Scalar quantity means the quantity which is only magnitude. You know the scalar quantity, and vector quantity means the quantity which is magnitude and direction are known as vector quantity. Okay. So this is the definition of scalar and vector quantity. So scalar quantity is the quantity which is only what? Which is only magnitude, and vector quantity is the quantity which is magnitude as well as direction. So this is the difference between scalar quantity and vector quantity. So next, write down, it is a scalar quantity. The SI unit, what will be the SI unit of mass? Anyone? SI unit of mass?
Kilogram.
Yes, good, kilogram. So write down SI unit of mass is kilogram, and or we can write kg. So it is measured by a beam balance. So write down, it is measured by a beam balance. It is measured by a beam balance. Clear? This is the definition of mass. Okay. So all of you write down the definition of mass. 1 minute. What finish? All of you finish the writing part. Hello.
Yes.
Yes. So next item weight. Next item weight. Next item weight. Weight. So the difference between mass and weight is mass is constant, but weight is not constant. Weight depends upon the value of g. Okay. So this is the difference between weight and mass and weight. So I don't know the definition. The weight of a body. I don't know definition. The weight of a body is the force due to which due to which art due to which art attract it towards towards its center towards its center. I done the definition up to this. Finish.
Yes, sir.
So the weight of a body is the force due to which art attract it towards its center. So this is the weight of the body. Okay. So next write down after full stop write down. It is a vector quantity. It is a vector quantity. It is a vector. It is a vector quantity. It is a vector quantity. Vector quantity means with has both magnitude and direction. Okay, so that's why it is a vector quantity. So next I done the SI unit of weight. SI unit of weight is Newton. Newton. Or you can write capital N. And it is measured by spring balance. Spring balance. And it is calculated by the formula. It is calculated by the formula W equal to mg, where m is the mass of the body, g is the acceleration due to Gravity. Finish? Who is this? Who is this? Kabirul? What have you imagined this is? All of you have your dinner, yes or no?
Yes.
Nayan? Can you hear me, Nayan? Nayan, can you hear me? Nayan, can you hear me, Nayan? Nayan, can you hear me? Iflina, can you hear me? Iflina?
Sir.
Yes. Nazia?
Sir.
Then Kabirul? Can you hear me, Kabirul? Okay. So all of you finish the writing this one? Definition of weight? Yes or no?
Yes.
Okay. So now see, weight is your, that means weight depends upon the mass and the acceleration. So mass will remain constant wherever you go. The mass will remain constant, but weight will change. That means now see, your weight or our weight in Earth is different, in Moon is different. Why? Because the gravitational force, that means the value of gravity, the gravity is different in compared to Earth and in Moon. Okay, so that's why that's why the weight will different for a different your place, but mass will remain constant. Okay, and that's why the weight of an object on the Moon is 1/6 of its weight on the Earth. That means suppose a small boy weight is 36 kg in the Earth, so his weight will be 6 kg in Moon because of this value of g. Okay, so that's why weight will differ, but mass will remain constant. Okay,
Yes, sir.
so write down weight. So weight is different for different place. Okay, write down like this. Weight of a body changes from place to place. Weight of a body changes from place to place. Weight of a body changes from place to place, but mass will remain constant. It will not change. Mass will not change, but weight of a body changes from place to place. Okay. Finish? All of you? Finish or not?
Yes.
Okay. So next, see your NCERT book. Weight of an object on the Moon. See the page number 137. All of you see the page number 137. See the page number 137. Weight of an. Have you seen all of you?
Yes.
Okay. So Porismita and what happened to Porismita? Nayan, can you hear me? Nayan. Nayan. So I done. Weight of an object on the moon. Weight of an object on the moon. You the heading weight of an object on the moon. Finish. Weight of an object on the moon. Weight of an object on the moon. So right, see this one. Suppose write down. Let the mass of an object be m. Let the mass of an object be small m on moon. Let the mass of an object be small m on moon. Next write down. Let not on moon. Don't write on moon. Just write down this one. Let mass of an object be m, small m. No need to write on moon. Next write down. Let its weight on the moon be w suffix m. Yes, I can hear you, sir. No one has messaged me. Why don't you tell me? Let its weight on the moon be Wm. So next I don't let mass of the moon. Let mass of the moon be capital M, small m, and radius of the moon be r suffix m. Also write down this one. Let mass of an object be small m. Let its weight on the moon be Wm. Let you be in suffix, okay? Wm. What is Porismita? Porismita has entered the room. So let mass of the moon be Wm. Sorry, capital M suffix small m. M means M denotes, okay? M denotes your mass, and small m denotes your moon, okay? In the same way, R denotes radius, small m denotes, that means this is the radius of the moon, this is the mass of the moon, and this is the weight of the moon. Let weight on the moon. That means let its weight means what? Let the weight of the body on the moon be Wm. Clear?
Yeah.
All of you? Now see, by universal law, what will be the force, gravitational force between the body and the moon? By universal law, what will be the force between the universal law of gravitation? Now see, what is the definition of weight? Just now I have given the definition of weight. The weight of a body is the force. The weight of a body is the force. See the definition. The weight of a body is the force due to which Earth attracts it towards its center. Now in case of moon, it will be the weight of a body is the force due to which moon attracts it towards its center. All of you clear the definition of weight? Clear or not, all of you? Okay. So see that's why I am giving the definition, because definition is very important for understanding. Now see, the weight of a body is the, all of you mute the sound. The weight of a mute, all of you mute the sound. Some sounds are coming. The weight of a body is the force due to which Earth now say in case of Moon it will be the weight of a body in the Moon is the force due to which Moon attract it towards its center. Now see, that means now what will be the weight of the body on the Moon? Now see, weight of the body. What is the definition? Weight of the body is the force due to which Moon attract it towards its center. Now, according to the definition and by the universal law of gravitation, what will be the weight of the Moon? Himkon, what will be the weight of the Moon? I don't. What will be the weight of the Moon? So I don't by applying the universal law of gravitation, the weight of the object on the Moon will be. Now see, weight of the Moon is defined as the force by which the Moon will attract the body. Yes or no? Yes, Nazia?
Yes.
Yes. So Wm. Now what is the force by which Moon will attract the body? What will be the force by which Moon will attract the body? This is given by the universal law. So what is the universal law of gravitation? Capital G into mass of the Moon into mass of the body. Yes or no?
Yes.
Mass of the Moon and mass of the body. Now see, this is the Moon and this is the body. This is the capital M and this is a small m. So what is the force between them? Now the weight of the body, according to definition, the weight of the body is given by the force by which the Moon will attract the body. Yes or no? Yes. The weight of the, according to definition, the weight of the body is defined as the force with the help of which Moon will attract the body. So that's why the force is given by universal law of gravitation, capital G, capital M, small m, by distance between them. Yes or no? By the formula is distance between them square. Now in the second class, I discussed these things. When a body is near to the bigger one, then the distance between them, we have to consider the distance between them as the radius of the bigger one. Yes? Yes or no? That day I discussed one thing. When a body is near to the earth, then the distance between the body and the earth is considered to be the radius of the earth. Yes?
Yes.
In the same way, when a body is near to the Moon, then the distance between the body and the Moon is considered to be the radius of the Moon. Yes or no? So it will be, that's why according to formula, it will be Rm square. All of you clear how we get the formula? Clear, all of you?
Yes.
Okay. Now see, this is the formula. This is the weight of the body. This is the weight of the body. Then again, see this one. Again, what will be the weight of the body? Now this is the weight of the body on the Moon. This is the weight of the body on the Moon. So give number 1. Give number 1. Now we have to compare the weight of the Moon with weight of the we have to compare the weight of an object on the Moon with the weight of the same object on the Earth. Yes or no? Yes. So this give number 1. Then again write down. Again weight of the body on the earth is given by, now it will be what? WE is the M means moon, E means earth. Clear? All of you? Clear or not, all of you?
Yes.
Yes.
Sir,
So
yes.
this is the mass of the earth, this is the mass of the body, and this is the radius of the earth. So I don't where you in here aside of the, that means here you can write where. In your at home you write down, just leave some space for here. I don't, M will be the mass of the earth, small m will be the mass of the body, R will be the radius of the earth. Clear? We will make it here, write down WE. All of you clear? Leave some space here. Now see. Now see. So again see in your book, page number 137, the mass of the earth and the mass of the moon is given, and again mass, radius of the earth and radius of the moon is given. Have you seen? Have you seen? Table 10.1. Have you seen the table?
Yes. Yes. Yes.
Sir,
Yes.
yes.
So, yes. The mass of the earth is given, radius of the earth is given, mass of the moon is given, radius of the moon is given. Now you have to put the value of this in these two equations. Okay, in these two equations you have to put the value. Now when you put the value, suppose when you put the value in the equation 1, so what is the equation 1? Equation 1 is your, so write down from equation, you have to write down here you have to write down, we know that like this, capital M small m and capital M small e, or small e small m, capital M small e and capital M small m. That means what? Capital M small e means mass of the earth, capital M your small m means mass of the moon, then RE and RM. So write down the value 5.98 into 10 to the power 24 kg, then it is your 7.36. We have only 6 minutes. 7.36 into 10 to the power 22 kg. Then RE will be your 6.37 into 10 to the power 6 meter, and RM is your 1.74 into 10 to the power 6 meter. So you have to put this value in these two equations. Now see, what is the equation number 1? Equation number 1 is your this one, WE equal to, sorry, WM. Equation number 1 is WM. WM equal to G. This is the equation number 1, yes or no?
Yes, sir.
Now put the value here. Put the value here. Now when you put the value, we know the value of G is what? No need to put the value of G, because G and G will get cancelled. So we have to compare now. So G, then small m will be this one, your 7.36 into 7.36 into 10 to the power 22 kg. Yes or no? Then small m is your, keep small m as it is, because m and, because we have to compare the weight of the mass, weight of the object on the moon and weight of the object on the earth. So then put the value RM. RM is your 1.74 into 10 to the power 6 square. Now it will be your, now when you solve this, your value will be this one. When you solve this, your value will be 2.431 into 10 to the power 10 G into small m. Okay. So this is the your, suppose, equation number 3. Again put the value in equation number 2, this one. So write down again from 2, W is your G capital M small m, that means capital M small m by RM. Sorry, it will be RE, not M. It will be RE. So in the formula also you can write this one. This will be ME. This will be RE. So now see, just put the value here. G into what is the mass of the earth? 5.98 into 10 to the power 24 kg. So just put the value 5.98 into 10 to the power 24 kg. Keep M as it is because we don't have value of M. And RE is your how much? 6.37 into 10 to the power 6. So when you solve this, your value will be 1.474 into 10 to the power 11 gram, sorry, not gram, G into, G means gravitational constant. So this will be 4. Now divide your 3 by 4. All have finished up to this writing? Have you finished?
Yes, sir.
Okay.
Sir, yes.
Okay. Now divide 3 by 4. Divide 3 by 4. 3 divide 4. So 3, that means left hand side with left hand side, right hand side with right hand side. So left hand side is your Wm by We. So it will be your Wm by We. Now what will be the left hand side, right hand side? Right hand side is your 2.431 into 10 to the power 10. So 2.431 into 10 to the power 10. Now see, why I have not put the value of G and M? Because G and M will get cancelled, yes or no? Now it will be
Yes.
1.474 into 10 to the power 11 into G and M. Now see, GMN will get cancelled. GGMM. Now when you solve this, your value will be approximately 16.165. 0.165. That means Wm by W is 0.165, which is approximately 1 by 6. That means when you divide 1 by 6, your value will be 0.165, approximate value. Okay.
Yes.
Everybody clear up to this?
Yes, sir.
Let me see. Now Wm by We equal to 1 by 6. So we can write Wm, when you cross multiply, it will be 1 by 6 into We. Up to this clear? So what is the Wm? Wm is the weight of the object on the moon. That is equal to 1 by 6 of the weight of the object what on the earth. Clear? So this is the proof. Weight of the object on the moon is 1 by 6 of the weight of the object on the earth. That means suppose one small boy's weight is suppose 30 kg. Suppose 30 kg on the earth. So what will be what will be his weight on the moon?
3 kg. 3 kg.
Hey, what do you mean 3 kg? On the earth is 30 kg. On the moon will be what? 5 kg, no? 1 by 6 of this one. So 5 kg, it will be 5 kg on the moon. Clear? Clear?
Sir, yes.
Okay. So today we'll end the class here because less than 1 minute we have. Tomorrow we'll discuss the difference between mass and weight and the other this one. And tomorrow if there is no cut down of electricity, then we'll start our class at 3 p.m. Okay, sharply at 3 p.m. Okay.
Okay.
So thank you. All of you leave the class now. Thank you. All of you leave the class.